Well, it's new tool day again. If this keeps up much longer, some of my poor woodworking tools are going to have to find new homes. Welcome back to Cloud 42. I'm James. One of the shops that I've spent some time in had a large industrial buffer that was set up with a Scotch-Brite deburring wheel on one end and a stack of non-woven pads on the other. And it was great for deburring parts after they come off the mill, or sheet metal parts after they come off the shear, or surfacing, giving kind of a brushed finish to the surface of an aluminum or steel part. And ever since I've had access to that, I have wanted one in my own shop. And it finally came to the top of my priority list, so I ordered one. Let's get into this box and take a look. I'm not sure exactly how to get this thing out. It is pretty heavy. Okay, this is holding it down. Pull that out. This is a Baldor 332B. This is the 3/4 horsepower version of this buffer, and it can be wired for 115 or 230 volts. This one is the slow speed, the 1800 RPM version. Now, when I ordered it, it said it was 115 volts. I'm looking at the nameplate here and it says 115 or 230. So does it say, let's see if I can read this upside down. This unit connected for 120 volts AC at factory. Okay, so there's instructions back here for how to rewire it for 220 or 230 or 240, but it's got a 120 volt plug on it and it's wired for 120 from the factory. Okay, so a little on-off switch on the front. Installation, maintenance, grounding, lubrication, and wiring diagrams. Whole bunch of warnings. And the on-off switch, the one important thing. Okay, that all looks pretty straightforward. It's got little rubber covers on here. Let me pull this off the nuts. Let's pull all the hardware off of this thing and spin it up and see how smoothly it runs. So left-hand nut here. We've got spacer and a couple of flanges. You may have seen recently, Adam Booth actually bought, it turns out, exactly this same model of buffer and set it up in his shop with a wire wheel and a Scotch-Brite wheel. And I believe he ran into a bunch of problems with these flanges not running true. So it'll be very interesting to see how they run here, if that was an artifact of the way the wire wheel was clamped, or if there's actually something wrong and we're gonna have to clean up the flanges. But I want to run this thing up with nothing on it, just to make sure that the shaft is straight and it's running smooth. Okay, let's see what we've got. That is nice. And I'm just feeling this central shaft to see if there's any run out on it. And it's not perfect, but it's pretty good. Not really feeling any vibration in the motor. I mean, I can feel that it's running, but that's nice and quiet, which is what I expected from a Baldor. Okay, these are, I believe, 3/4 inch. Let's see, the overall shaft here is 1/160, 1/160, and then the actual shaft is 3/4. So let me get some wheels and let's set this thing up and give it a shot. Okay, on the left side of this, I'm going to set up a Scotch-Brite deburring wheel. This is what they just call an EXL deburring wheel. So this is a soft material. It's kind of rubbery, it's kind of fibrous, and it's got grit embedded in it. So it's not a stone wheel. You can't ring it. It's just dead. but it's soft and it's really great for taking burrs off of edges or polishing surfaces. So it's got an arrow here showing which way it needs to turn. And unfortunately, this has a 1-inch center hole, and this is a 3/4 inch arbor. So I ordered a package of reducing bushings. We'll figure out which one we need. Yeah, that's 3/4 of an inch. And start with a flange. Then put the reducing bushing in here. Slide that on. The bushing's tight, which is great. It'll be great if I can get it on. Sure, I got this turning the right direction. And this has a spacer, but yeah, that'll work. I'd prefer to have all of the threads, so we don't need a spacer with this. Yep, there we go. Let me grab a wrench so we can snug that down. Okay. And then because of the way this spins, that'll actually tighten down as it runs further. So before I spin this up with the wheel on it, let's talk a minute about safety. Got safety glasses. Those are going on. My wedding ring in this scenario and watch are really not a safety risk. There's not an entanglement hazard. I don't have long sleeves. I'm gonna take them off anyway because it'll just save me some time in the comment section. Now, this wheel is not a stone wheel, so I can't ring it. The risk of it fracturing and exploding is relatively low, again, because it's a compliant material. But any new wheel that I spin up, especially on a machine like this that doesn't have guards in place, I am going to stand to the side while it spins up and give it a little time to settle in and just make sure that nothing is going to fly off of it. I'm going to stand off to the side and spin it up. Okay, that seems to be running pretty true in terms of wobble this direction. I'm not really seeing much. There is a little bit of run out in the radial direction, and I'm going to attribute that just to the new wheel. And then as I run the wheel and actually run parts against it, I'm assuming that is going to clean up and center itself. But what I'm not seeing is just the crazy wobbling that I know Adam Booth was seeing when he set his up. This looks pretty good. I'm happy with that. Let's turn our attention to the other side. These are the non-woven pads that I'm going to use on the right side of this for buffing parts and surfacing. And these are Scotch-Brite pads. These are 8 inches in diameter. I think they're about 1/4 of an inch thick. They're soft, so what does thickness mean? And they have a 3/4 inch hole in the center. And as I was shopping around trying to find these, I've seen these on buffers like this in other shops, but I have not been able to locate these. It took me a while, and the biggest problem is finding them with the 3/4 inch hole. You can get them with 5/8 holes, you can get them with 1/2 inch holes, you can get them with 1/4 inch holes, but finding these with a 3/4 inch hole to fit on this buffer shaft has proven a little bit difficult. I did finally find these at MSC. I will put a link down in the description. But let's go ahead and load these up. I've got a whole bunch here. I have no idea how many will be the right thickness. Start with the flange. I don't know if you can see that, but there's a little pin that serves as a key in the shaft and a little keyway in the part, in the flange. So that goes on there. On 1, 2, these fit pretty close. 3, let's see that. Just trying to decide what that looks like. That looks about right to me. Put it on the flange, that'll crush down. Yeah, that seems pretty reasonable. Throw on the nut and let's see, how tight do we want to run that? I think that's actually going to be okay, even though it's not super tight. I kind of wish I had something for that to bottom on, but it's probably not necessary. Don't want to grind up the shaft. Well, that seems pretty reasonable. Let's see what that looks like spinning. See if those wobble all over the place. And again, I'm going to stand to the side just in case something flies off of it so I won't get hit in the face. Just feeling the outside of these flanges, they seem to be running pretty true. That one's got a little bit of axial wobble. And looking straight down at it, of course, these are floppy, so they're moving around a little bit. Putting off quite a bit of wind. Maybe you can hear that in my microphone. My apologies if you can. Okay. I'm reasonably happy with that. I'm not feeling the need to go throw the flanges on the lathe. It's running pretty true. Let's get some parts, try it out. Okay, I've got some parts here that we can try out on the buffer. This is a piece of sheet metal. This is 5052 aluminum, 1/8 of an inch thick, and this was cut on a shear. So there's a nice sharp, see if you can hear that. There's a nice sharp burr right down the edge. This is very typical of sheet metal parts. I've got a piece of 1018 steel, and this has just got some saw cuts on the end, so there's burrs on the end from the saw cut. And then I have one of these. You saw this in a previous video. This is a CNC machined aluminum part. This came right off the mill, so it's got nice sharp edges that have not been deburred at all. I didn't touch it. I knew this video was coming, so I set an extra one aside. And then of course this has got the paint on it and the markings from the factory, so it's also a good candidate for surfacing. So let's give some of these a try. Before we jump right in here, let's talk about how to address the wheel. Of course, I'm still wearing my safety glasses. And you might have noticed there are no guards on this machine. And as long as you address the wheel properly from the right angles, this will be fine. In fact, having it open probably adds an element of safety because it gives room for the part to kick away from the wheel if you run into a problem. So if I want to surface, or if I want to deburr this top edge here, I want to address the wheel below the center line and come in at an angle that will address that, such that if it grabs the wheel, it will just push it away from the wheel and will not cause a kickback. If on the other hand, I came in, the wheel's turning this direction, if I came in and tried to deburr that edge coming at this angle, then if it catches in the wheel, it's going to shoot the part back at me. And the same thing's true when you're doing the corners. You want to be holding it so that the line between where you're holding the part and the point of contact, that line, if you continue it out, it comes below this center shaft. If I'm holding the part and coming around like this, my contact point is down here. That's where I'm holding it. The contact point with the wheel is up here, and the imaginary line through that goes above this shaft. So if it bites, it's going to kick it back towards me. Where if instead I'm holding it up here and coming in and dressing the corner in this way, then from the point where I'm holding it, that line goes below center. So if it grabs, it's just going to push this away from the wheel. And as long as there's space here and nothing for it to grab against, I mean, obviously if I get under here and I have a scenario where I can pinch it between the work surface and, let's see, you can't see that. If I get into a situation where I can pinch this between the wheel and whatever's below it, that's obviously a problem as well. Ideally, this buffer would be sitting up on a pedestal, so I'd have just free open space under it. I will try to find a place like that in my shop, but my space is really limited, so I'm just going to need to be very careful about making sure I'm not in a situation where a part can get grabbed under the wheel and jammed against the work surface underneath it. So again, it's just you're trying to make sure that the line of the rigid part from where you're holding it to the point of contact on the wheel goes through below the center axle, and it won't kick back, it'll simply push away. So let's give it a try. I'm going to stand back stand out of the way of the wheel when I spin it up, of course. And there it is. Now this is the sharp edge, and I'll just take it across the wheel. Just like that. That burr is completely gone. You can see I haven't done a lot of surfacing on the material, so it hasn't messed up the finish. It just took the burr off the edge. Now flip it over. I don't want to come into the wheel like this, so I flip it over and come underneath. And all those edges are now soft. They are rounded slightly, so if you want a super crisp edge, this is probably not the technique for you, but just taking that off so that it's soft without really marking up the surface of the part is really nice. So these corners are still sharp. Now I'm going to do the same thing. Now if I held it down here and tried to come in, there's a good chance it's going to grab and kick at me. So to do this corner, I'll just hold it at the top here, and I can just lightly do that corner. I can do it from both sides. And now I've got nice soft corners, edges on the whole thing. Okay, let's take the sharp burr here from this saw cut. And that is pretty much gone. Place there was a heavy burr, took another swipe. Looks pretty good. Kind of shined up the end. That's just the saw cut, of course, but compared to the dullness, that's pretty nice. Let's see, can we do some? I think this is probably a better application for the soft buff on the other end, so we'll try that in a minute. And we've got some complicated inside corners. Again, just same thing. I'm just going to hold it and try to come in a way that the line from where I'm holding it to the contact point on the wheel goes below that shaft. And that is beautiful. And all those edges are nice and soft. Nice. Now these inside edges, you can kind of come in like this, but you're really doing more surfacing on the part than you are really doing anything on the edge. You can't really get at that here. Okay, well now let's try the soft buffs on this side. And these are going to be more for surfacing. I can try running them around the edge. I'll try running them around the edge of the sheet metal first and just see how much they affect the surface. And you can see there's much more of an affected zone. Maybe you can't see that. I'll exaggerate it. I think you can see that. There's much more of a zone around the edge there that's been kind of polished or kind of brushed. And it's great for cleaning it up, and it does a nice job of rounding over that edge and making it smooth, as long as you're not worried about the affecting the surface. Now in this case, I do want to affect the surface of this part. This thing's throwing a lot of wind here. I'm not sure if that's hitting my microphone. If it is, I apologize. So let's take a look at, let's try surfacing this. Same thing, need to keep the point of contact where I'm holding it versus the point of contact on the wheel so that that line goes through below the center line so that it won't kick back. Pretty nice. Wow, beautiful brushed finish, and because I went across those edges are softened a little bit as well. Now here I've got some burrs on these holes, do the same thing. Very nice. And we'll do the inside edges here that have the paint and the burrs from the countersinks. It's a little harder to hold on to in this case. Oh, that's beautiful. That is hard to beat. Okay. Let's see what we can do buffing off the little bit of rust, surface rust, and scale on 1018 steel. Well, that's probably not ideal on the round surface just because it's hard to feed in there. Let me see if I can find something flat. Here's a piece of 3/4 inch flat square bar. And the buff kind of cleans it up a little. Let's try the Scotch-Brite wheel. And yeah, that's even better. So for taking out tooling marks off of the mill, this would also be ideal. Unfortunately, I don't have anything steel that is milled right now with tooling marks in it that I can just grab on here and test it. But the next time I mill something, you can bet I'll be bringing it over to this buffer to clean it up. Well, that's all I have for today. You can see these wheels are already starting to fray a little bit on the edges and soften up, and that's exactly what you want. These are gonna ultimately fuzz out, and it'll be a nice, smooth, fuzzy kind of a surface that you can run parts against to surface them. And I think this is gonna work out really well. I think this is gonna be a great addition to the shop. Well, that's all I have for you today. If you're enjoying these videos, give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. Feel free to comment down below if you've got a buffer set up like this, or if you have some other setup that you prefer for finishing parts after they come off of the machine tools. I'd like to hear about it. Who knows? I may find yet another tool that I can't live without. Thank you for watching.